flow is actually more the pitch of an idea or the invitation to participate in a growing research effort than an actual research result. Some people call it a vision, but being in Berlin, so the capital of Germany, there is an old quote by Helmut Schmidt, one of our previous chancellors: if a man has visions, he should go and see a doctor. So we call it an idea. Okay, whatever's going to come now is joint work with Kai-Uwe Kühnberger, the gentleman back there. Hello, Kai-Uwe. Artur Garcez from London, Alessandro Saffiotti at Örebro, Martin Fischer from Potsdam, which is a city nearby, and Bundy from Edinburgh. And another quick primer. I think I'm preaching to the choir, or at least I hope. But let me refresh you on what's the difference and the connections between symbolic and sub-symbolic computation and representation. So classically, the AI world falls in two parts: symbolists and connectionists. Connectionists being the people who like fumble around with networks, symbolists being the guys who like push logical formulae downhills, uphills, wherever. There is quite some connection between both paradigms, namely, in terms of computability, Turing already, well, made the claim that all of it is the same. There is the thesis by van M. de Boas that all reasonable architectures actually come down to the same, at least when implemented in physical devices. And there is a beautiful theorem from Hannes Leitgeb from 2005 in which he shows that both in representational power and in problem-solving power, localized representations of system C, so some non-monotonic logic, and distributed representations reducible to dynamical systems are equivalent, up to a polynomial overhead. Good. So basically, symbols and, well, distributed representations are equivalent for all practical purposes in theory. Nonetheless, as most of us know, and many probably have experienced, we don't really know how to do symbol-y stuff with networks and how to do networky stuff with symbols for most cases. This in the background. Let's have a look at the talk. So, at first, I want to amuse you with an analogy taken from music and transferred to computer science, mostly due to Kai-Uwe. Secondly, I will actually tell you why I annoy you with that analogy, and then we will have a look at how to usefully, well, apply the analogy. So, if you have a look at what's knowledge in natural agents, philosophy falls short, and philosophy knowledge is defined as justified true belief. Still, that's usually not what you would expect if you talk to a natural agent. So for us, knowledge can come in very different forms. It can be multimodal, can be grounded, embodied, situated. We probably have many different layers, like from simple sensory motor contingencies and interactions up to Pythagorean theorems or quantum mechanics. We flexibly adapt knowledge, be it in social interaction or just in everyday life. Like, it's actually pretty messy and it's pretty diverse. So, if you have a look at music, how does music work, at least in its, say, analytical stage? Well, on the one hand, you have a physical level, which is the mere audio data. You then, on top of this, can define a media level. You can analyze it in terms of chord progressions. You have a harmonic level, a melodic level. There is some rhythmic analysis possible. You have the level of score. You have the level of structure of a piece. And then you even have a semantic meta level. So there also is lots of different levels, some of which straightforwardly relate. So translating MIDI to score data to harmonic structure works pretty well. Some of which are partially translatable, so harmonic structure to score, rhythmic to physical level. Some of them have fairly fuzzy, vague, or tentative connections, melody to harmony, physical structure to structural level. And some of them simply do not go together, like you cannot get one from the other without major magic. Try to go from MIDI to the semantic meta level. So, also pieces of music are multi-layered, multi-representational, a tad similar to what probably knowledge is in application. So, when you now have a look at how music works and how it actually is treated by working musicians, if you change something in one of these layers I mentioned, you mostly have natural changes occurring in the other layers as well, at least in those which have a connection. So you can use these connections in order to also get some internal data and some insight about how the piece of music works. So you can do multi-representational analysis to detect or learn mappings between these layers just by observing, to find novelties and correlations, to systematically unfold specific properties, or to find invariance. Okay, so now back to the agent setting. Go back to what I said at the beginning, from sensory motor contingencies up to the level of actual knowledge. So what you can imagine is that a neural layer is learning on the perception level, then you follow up with what's called an anchoring level, which basically is grounding just in situations. So this remote control is this remote control is this remote control. Then you actually can go up to reactive layer, which is the first behaviorally relevant. Then presumably, hopefully, you can bootstrap this into even higher levels, up to a symbolic level for actual high-level planning, and probably even to something which allows you to develop a core ontology. All of this shouldn't really be news. We just don't know how to do it, I hope. Like, I hope it's not news. I don't hope that we don't know how to do it. So, carrying this on, if we now think back about the music example, where if you fumble around on one layer in one way, the others react in a certain way in order to keep the equilibrium, you actually can expect the same for an agent. Once you have it set up in these hierarchies with given connections, which can possibly be hard-coded, as soon as you start changing one of the layers, be it the lowest neural perception one, be it the highest ontological one, this should somehow go through the other layers and lead to according changes there in order to, well, keep what we call the pre-established harmony, or to just like keep the thing consistent. So, what we actually hope is that a simulated or actual system or agent operating on some of these interacting levels in multi-representational manner should allow for mechanisms or interactions similar to the music case. Okay, and now we jump into this Aiken grounding knowledge in action thing. What is the core idea of this entire endeavor? Well, the core idea is to develop theoretically and practically a conceptual framework and corresponding architecture which model an agent's knowledge, thinking, and acting as interrelated parts of a unified cognitive capacity. Doesn't sound like news, probably just sounds crazy, but keep in mind what I said before. We don't say we do this ex nihilo. We just say that, okay, there should be a way of establishing layers with original correspondences and then to get the dynamics in these layers right, up to the level of also adding knowledge to them. It's not creating from the start, it's actually taking a setup system and running it forwards. So our basic commitments are that knowledge is a multi-layered phenomenon, differing strongly with quite some schools in AI and especially in philosophy, that there is interaction between these levels, which can range over several levels and which does not always have to be sharp and precise, and that there is a huge influence by interactions between agents, the environment, everything you can perceive. So knowledge is not limited to an agent within, but it is a situated process, although there clearly is a strong mental level. And if you now have a look at the status quo in several other fields, what we advocate here also, I hope it sounds fairly commonsensical, would mean a radically new paradigm in terms of interaction styles, and that it's action-centered, embodied, and multimodal. In terms of knowledge repositories, as you would try to actually get different levels and forms of knowledge to interact, multimodal, hybrid, basically all the neural symbolic part, and also in terms of user modeling and communication through learning and adaptation. So, going through the individual goals in detail in order to also give you maybe an idea of how this could work. On the embodiment level, what's actually the idea is to learn of elementary forms of multimodal representations from agent interaction with environment. There is quite some work in cognitive psychology on how people do embodied learning. So it might sound a bit remote, I think it actually is, but there is quite some insight on how children actually learn counting by manual manipulation of, well, finger counting. There is also quite some work on other influences of embodied paradigms on learning, which this far, to a certain extent, have found entrance into robotics, but very little into AI. Starting out with these foundational studies, clearly it's not enough to just look at a child and say, okay, it's moving its finger when it's learning counting. That doesn't help us a lot. But there is by now quite some approaches from computational neuroscience and network-level cognitive modeling as, for example, concept tours, lately propagated mostly by Herbert Jäger, which seem to allow to actually get out of a dynamical systems representation a basic logic operation. So you can do top-down control of a dynamical system network, which previously was fairly challenging to get. The idea would now be to try, okay, go to the psychologist, have a look at what they do, and try to model it on a dynamical system layer, as this naturally bridges into neural networks and connectionist paradigms. Then comes the anchoring. So here roboticists are mostly active. Remember the remote control? It's actually the idea of tracking objects and elements of the world throughout the flow of time. Someone yesterday said that we need 4-dimensional representations because, like, you have the 3 visual ones and the temporal. Pretty much this is anchoring. You don't try to do meaning grounding, the philosophy-loading thing. You actually just try to do, well, you try to keep track of what's what and what things do. Still, it's everything but trivial. So there, what we actually hope to do is to expand the existing anchoring frameworks in robotics to grounding not only objects, but also to ground general observable properties appearing in the environment. There is a bit of theory by Peter Järdenfors on his conceptual frames, which we hope you can use there. Well, whether it works, that's up to time to show. But the basic idea would be that instead of also only tracking things, you allow for the dynamic introduction of new symbols for new objects and categories by trying to, A, keep track of what's there so that you can tell what came new, and by then being able to integrate this into your ontology. Also, once you have it in a, well, call it a proto-ontology because we are not yet at the highest symbolic level, what you hope to do is to establish analogical links across agents. So you would hope that if 2 agents perceive the same object, although probably in different representation languages, modalities, what have you, you still are capable of doing something like cross-informed learning. So you are capable of exploiting the, well, world-mediated relations between both. Then, following this anchoring process, which still actually operates on a fairly low neural level, so we are still talking about recognizing patterns and streams. We are not yet pushing symbols. We hope that on a neural level, what we can do is to specify a lifting procedure producing descriptions. So lifting these grounded situations and anchored objects and action patterns to more abstract symbolic representations. We don't claim that we actually make meaning of the world. So lifting does not mean that I identify a chair as a chair from the beginning. Like, it's not that I all of a sudden know what's a chair, how it feels like to sit on it. Keep phenomenology aside for the moment. What we actually claim is that using some deep learning, probably restricted Boltzmann machines, because one of our guys knows how to use them, you can actually bootstrap patterns up. So once you have it at a higher knowledge level, what you can do is all these operations on actually rich knowledge formalisms. So you can try to do repair mechanisms, reformation, you can try to do high-level analogical computing. And as, of course, I'm running out of time, let's jump to the overall account. So the basic idea is to ground knowledge in cognitively plausible multimodal interaction paradigms, to lift these grounded situations into more abstract representations, then do reasoning by analogy and concept blending in order to create and to find structure. And what you find there probably is partially inconsistent, incoherent, or just odd, so you want to do repair on these levels. How can something like this look like? Yes, there is a basic sketch of an architecture for which I will sacrifice the last 2 minutes. Well, come on, 2. So what you actually do is on the cognitive foundations level, you get via conceptuals and your network representations, so dynamical systems. You actually get input and patterns in data. These objects, via anchoring, then can hopefully be put in a concept hierarchy. You lift these still subsymbolically represented concepts into symbolic representations by assigning formulae or, well, syntax. Once you have the syntax, presumably analogy making actually can tell you, well, there are relations in the structure, Most analogy engines work not on the semantic content, but on the syntactic structure and the functional nestings. And once you have the structure, you can actually see whether your ontology already accommodates for it or whether you have to adapt it. Clearly, right-hand side, once you change your ontology, this also triggers down again because it informs your analogy process and it also informs your anchoring patterns. And final disclaimer, because repeatedly we actually got the comment, well, people, that's just data fusion. No, that's not just data fusion. Data fusion, I read out the definition. Data fusion techniques combine data from multiple sensors and related information from associated databases to achieve improved accuracy and more specific inferences than could be achieved by the use of a single sensor alone. Actually, that is a totally different ambition than what we hope to do. So what we actually hope to do is to develop a cognitively inspired combination of low-level sensing, high-level reasoning, and the loop back in an attempt of anchoring symbolic knowledge and sub-symbolic perception and interaction in a continuous perception, sensing, action, perception-action thinking loop. If this works, it would, in our opinion, be a significant step towards the recreation of a foundation for cognitive capacities and forms of reasoning in next-generation AI systems, and it would make for an amazing computational test bench for current theories from cognitive science. So, if there should be questions, comments, criticisms, or ideas, I think there will be a panel discussion afterwards, so feel free to shoot on site. Otherwise, if you actually just want to join, this is the email address. And yeah, as I said, soup coma, there's an XKCD. Thank you.